Okay, today we're going to go over sections 3D and 3E. We'll really focus more on 3D. 3E is more for you guys to read and look through than for me to actually kind of lecture on, but we'll talk about it. Before we get started, though, the next class is a test. So, we won't have regular class again. You'll just go in and take the test on Wednesday. Give me 1 second. Let me make sure I've got this put in the right folder. And just like before, I mean, the setup for the test is the same as it was before. I think this one will be a little bit easier on the setup because it's not full of diagrams and things of that nature like the like test one with the logic. That was just, it was tough. Like, I know we had that Venn diagram issue where there was that one question where I couldn't get that Venn diagram on there correctly. That was a user error. That was not a Blackboard error, by the way. I don't want to say it's a Blackboard issue and it's really me issue. But let me get this in here. Hold on. There we go. So today, though, we're going to go over, again, 3D, which is over kind of index prices, which is neat. It's really real world math at its finest, actually. And then 3E, though, is more over how numbers can be deceptive. And I'll tell you when I get to 3E, the questions on the test that are going to be over 3E are going to be very similar to the homework. Like, I might just steal one, copy and paste, and put it in the test because it's hard to really ask those. They're very kind of subjective questions in a way, some of them. The more objective ones are the ones I would kind of focus on. So we'll get there. I'll go over that. I don't think it'll take us the whole hour and 15 minutes. I don't think we'll have to go over. These two sections are pretty short. So do you guys, Michaela, I think, and Weston are in here. Do you guys have any questions before I get going? Oh, there's Ava. If not, that's fine. If you want to put them in the chat, my chat's over here. If you want to put in the chat, that's fine as well. But let's start on 3D. So 3D is over index values, and it focuses on the CPI, the Consumer Product Index. We'll get to that really in the first kind of example. But first off, let's talk about index values. Let me switch over here to the document camera. Boom. Okay, 3D. It's really about index values. And again, your book is going to focus on the Consumer Price Index, which is just a really good example, real world example of an index value. So first off, let's just define it. I'm going to look at that bubble on page 163. And it says an index number provides a simple way to compare measurements made at different times or in different places. The value at one particular time or place is chosen as the reference value. The index number for any other time is given. So the little formula, which all these formulas kind of are very similar, the index number is going to equal the value for that year over the reference value times 100. Now the 100 again is a percentile, so times 100. Note there's no particular rule for rounding index numbers, but in this book they're going to round to the nearest tenth, so we'll just stick to that value. We'll round to the nearest 10th place. So I'm going to use the book here, so you don't have to have it open, but I'm definitely going to be referring to it a lot in this section because there's nice charts in it. If we look at the bottom of page 162, there's an example of average gas prices. Okay, and then we're gonna find one of these index values for the average gas price and just really focus on how to interpret. On this test, we're going to do a lot of interpretation when it comes to the index number, not just finding it, but also interpreting it. So if we looked at, let's look at two different years. Let's say we looked at, now in the book, it's got 19, let's look at 1980, where the price of gas, this is the gas price, was $1.22. And then let's look at, let's say 2000. 2000, the gas price was $1.56. So if we wanted to find the index, now we have to choose which one of these we want our reference value. I'm going to make the reference this one, but just because it was the previous year. Okay, that's the only reason. Since the oldest year, I should say, the oldest year is 1980, so I'll make that the reference year. And let's find this index for really 1980 to 2000. Okay, so this is going to be the index value from 1980 to 2000. So if I want to find the index, it's going to be now the more current value. So $1.56 divided by the reference value, which is $1.22. And then we're going to multiply it by 100. Now I'm going to take my calculator out and do this. And they said to round to the 10th place, right? So $1.56. Now we don't have to worry about units here because the dollars cancel. An index value does not have a unit, okay? It's a reference number. So 156 divided by 122 times 100 is 127.9 if they're rounding it to the decimal place. Now what this means, in terms of 2000, the price is 127% more than 1980. So 127% more than 1980. If it was the same, it would just be 100, right? So this means there was a 27, well, I should say 0.9%, if you want to put that down there. I already wrote this in Sharpie. So 27.9% increase in the price of gas. Or it's really an average price, but we'll put that in there. Average price of gas from 1980 to 2000. Okay, so that's what the index tells us. It just tells us the average increase or average decrease for this product. It was the price of gas. Okay, let's see if I've got like the current, maybe like the 2020 average price of gas in 2020, which it tanked. Let's do 1999 or 2019 average price of gas 2019. They're telling me just online it's $2.60. So that's the average price of gas in 2019. So if we want to do another one of these, let's make the reference number, let's change it up just for fun. Let's do 1990. Or actually, let's just do 2000. See how much it's changed since 2000. We know 2000s. I wrote it up here. Guys, if you just got into the class, I'm really looking at page 162. It's got charts at the bottom for the average price of gas. Now, I just Googled 2019 for that one. So if I want to find the index value for this one, so the index is going to be the most current value, so 260 over $1.56, and then I multiply it by 100 to get it to a percentage. I know your book doesn't write the percent in there, but really the point is it's making it into a percentage. So for this one, 260 divided by 156, $1.56 I should say, times 100, we wind up with 166.7, that's a percent. I ran out of room, so I'll write it down here. 166.7%. So it increased from 2000 to 2019. The price of gas increased 166.7%. Okay, kind of neat. So really, it increased 66%, right? The price of gas increased 66% if you want to think of it in that way, right? If it would have stayed the same, it would have just be 100%, right? If it's the same, it's 100%. So it increased really 66%. It's 66% more than 2000. Okay, you can kind of see that the book does this on page 163. It does, and those are just really kind of good examples and good interpretations, I should say, as well. And then it talks about using, reference years as well. I think your book does this. Yeah. Your book does it with reference years as well. And let's look. So again, if you go back to page 162, let me get a new sheet of paper. 162, on the left, you can see the price index where they stuck 1980 as 100. So what they've really done is they've used the reference of 1980. That's the reference value, right? And notice it goes up and down. Like in 1960, if 1980 equals 100, 1960 is 225.4, and then like 2010 is 232.8. And then, excuse me, if we do this, then we can kind of get a quicker index number, or a quicker difference, I should say. So if we look at comparing indices, this is in the middle of page 163. And it says, the primary purpose of index numbers is to facilitate comparisons. For example, suppose we want to know how much more expensive gas was in 2000 than in 1980. We can get the answer easily from table 3.2, which uses 1980 price as the reference value. This table shows that the price index for 2000 was 127.9, which means that the price of gas, of course, was 1.279 times the price of 1980. So yeah, we didn't really talk about it like that. But when you get the index number of 127.9, this means for 1980 to 2000. What this actually means is the price of gas is 1.279 times higher. In 2000 compared to 1980. Now, earlier I said, oh, it's 27.9% higher. That's still true, okay? That's still a true statement. This is just another way to word it, okay? It's just another way to word it. So it's 27.9% higher. It's 1.279 times higher. That it's really the same thing, just written two different ways, okay? The book then goes on, we can also do comparisons when neither value is the reference value. For example, suppose we want to know how much more expensive gas was in 1990 than 1960. We can find the answer by dividing the index numbers for those 2 years. Now notice the index numbers in that chart on page 162, they're referring to is 1980. So what it means is 1980 is kind of the main reference. That's going to equal 100. And all you have to do is really divide by these two numbers, and it's going to give you the index number, which is nice. So this works if you have a column where they stick an index number as really a constant variable in a way. It sticks an index year, I should say, or a year as a constant. So if we look at that, all we have to do is, since they give us an index number for both those years compared to 1980, we can just divide them. So we'd look at the index. I'm going to expand this out. The index from 1980 to 1990 over the index from 1980 to 1960. Okay? They don't say that in there in the middle of that page. I just want you to know where it's coming from. So if you already know the index number from the same year, you can just divide it on top and bottom. So what that chart says on 1990, it's 100.8. And for 1960, it is 25.4. And you wind up with almost 4, right? Yeah, 3.97. So the price of gas in 1990 compared to 1960 was 3.97 times higher, or 397% higher, which is kind of crazy. Okay, kind of neat. Question so far. I know I'm kind of zooming through this, but also your book does really good examples. Your book really covers this well. Okay. Let's look at their example. On page, this is example 3. So it says on page 164. You've got another chart on 164 that also adds a different reference year. It's the reference year for 2000. So the question says, using the 2000 price as the reference value, find the price index if today's gasoline price is $3.77 a gallon, which it's not, right? We'll do today's price. Why not here in a minute? But Let's say it was $3.77 a gallon. Use the 2000 price as the reference value. Find the price index if today's price. Okay. Compare your answer to the answer for the same gasoline price in example 1. Did we do example 1? Oh, 3 or 9. Yeah. So example 1, where 1980 was the reference. Okay, so let's do today. So again, it's just today's price over 2000 price times 100 because we're referencing it compared to 2000, right? So it's going to say 377 divided by the 2000 price, which was, let's go back to this chart, $1.56 times 100. So that winds up being 241.7. Okay. So from, I don't like this example because it's not today's price, but theoretically, if today's prices was 377, we know it's jumped 241, right? 241% above the 2000 price, where the example before jumped like 309%. If you go back to example 1 from, was it, let's see, example 1. It went from 1980 to, oh, they said 377 was the current from 1980. Okay, so from 1980 to 377, it's a 309% increase. And then from 2000 to 377, it's a 241.7% increase. So it's just showing the difference how even though it jumped 241.7%, or yeah, it's still not as high as going from 1980 to current, okay, which is an even higher index. And really what we're going to see today, it's weird because gas really has dropped over the last year. So, I mean, our gas prices right now are what, about 220-ish? I mean, somewhere in there. And you got to think the price, they're saying the gas price in 210 was 284. So it's gone negative, really. Let's look and see what happens when that happens. Let's look and see what happens with the price increase. We'll see that it's going to be less than 100. Let me get a piece of paper here. Let's say we went off their data, 2010, not 210. 2010, the price of gas they've got is 284. And right now, we're just going to say current 2020 price. I'm going to say it's 220. I know it's probably something different, but let's just say it's around 220. So again, we're going to do our value over the reference value, right? Our value over the reference value. Well, our current value is 220. The reference value is 284. So times 100, you wind up with 2.20 divided by 2.84 times 100. I get 77.5%. So we're paying 77.5% of the 2010 price because it's gone down. And look, if it goes down, this number is going to be less than 100, right? 100 would be if it stayed the same. Look, if it stayed the same, if the price in 210 was the exact same price in 220, 284 over 284, this would be 1. And you multiply by 100, you'd get 100. So if it stayed the exact same, this number would be 100. If it's above, it means you're paying more, right? For this example. If it's below, it means you're paying less than before. So kind of neat. So if this number, if the index winds up being less than 100 and really less than 1 in a way, right? It's also written as what, 0.775. So you're paying 0.775 times the 2010 price, right? I mean, if you got your calculator up and you put in 2.84 times 0.775, you get really close to 220. Now there's a rounding issue, but it's still 220, right? You'd be paying 220 a gallon. Okay, kind of cool. I know, you don't have to tell me. Okay? I mean, you could do this with housing prices. You could do this with anything where you know a nice average price. Another good example of this would be, like for a current example, it's kind of a hot button topic. Minimum wage. We could do this with minimum wage. I think I looked this up earlier. Oh, did I? No, there it is. Yeah. So if we wanted to get kind of an index of minimum wage, let's see here. The annual minimum wage. I know my first job was in like 2000, so we'll do that. In 2000, now this is the federal minimum wage. So the federal minimum wage in 2000 was $5.15. Now, of course, cities and states might have different laws, but the federal minimum wage was $5.15. The current minimum wage, is it 11? Is the federal 11? Or is that an Arkansas thing? Hold on. Current, I don't know off the top of my head. Federal minimum wage. Oh, no, current federal minimum wage is $7.25. That $11 thing is an Arkansas thing. So $7.25. So the federal minimum wage in 2000 was $5.15. The federal minimum wage now is $7.25. So I just want to know, how much did it increase? I mean, of course, we see that it increases, right? It's not going to decrease. So what's the index value for that? So to find the index value, we're going to put the new value, 725, over the reference value times 100. So let's see here. 725 divided by 515 times 100. Oh, 140%. So it really rose 40%, or it's 1.408 times the federal minimum wage from 2000. Okay. Okay, another way to think of this is how much did it rise on average per year, right? Look, we know that it rose 40.8%. Now, from 2021 to 2000, that's 21 years, right? 40.8 divided by 21. So on average, it rose 1.94 percentage points. It's not really percent, but 1.94 percentage points each year. Okay. And that's when they start arguing. We're going to go into inflation here in a minute. We can look back at this federal minimum wage when it comes to inflation, but that's when they start arguing, hey, there's no way that this minimum wage is right because in the past there was a higher value on it. We'll get to that actually when we get to inflation. So are there any questions though about making an index or the consumer price index? I'll give you just a minute. If you've got a burning question, I'll give you just a minute to type it in or to just yell at me over Zoom. Either one's fine. Either one is okay. Okay. So now let's look at inflation, what I was talking about, because rate of inflation is a good usage of indices or indexes. So your book, this is on page 166. I'm just kind of chatting about what's on the page. In the middle, it says the rate of inflation refers to the relative change in the consumer price index from what, oh, we didn't talk about consumer price index. Let's go back one. Yeah, let's start there. So the CPI, the consumer price index, this is on page 165. Consumer price index is based on an average of prices for a sample of more than 60,000 goods, services, and housing costs. Okay, so it's an average price of goods. I'm just going to say goods, services, and housing costs. But what's nice is it's an index already, okay? It's computed and reported monthly. If you just Google CPI, you'll see, I think I did it earlier. Yeah, I Googled just CPI from certain years, and the Bureau of Labor and Statistics, you'll see probably the last decade pop up first, but you can even get the CPI for like areas, and for certain data, they have CPI for like cities, and it's kind of how they adjust wages a lot of times. Like if you've heard this before, like, oh, well, if you go to, work in Washington, D.C. or to Chicago, you need to make more than your salary here because, rent's higher and the price of goods are higher. Well, that's based on this CPI. It's a cost of living CPI. Okay. And businesses will typically take that into account. And it's also why, like, whenever, and I'm not trying to be a pro con on federal minimum wage stuff. I know it's just a current political issue, but whenever they make a federal minimum wage, the cost of living throughout the U.S. is a lot different, right? So it should be the minimum throughout the U.S., where each city or state probably, they do create their own for a reason, okay? And it's because the cost of living should be different, and it's just different throughout the U.S. Okay, so consumer price index though. So let's get back to that. Your book does a good job of kind of showing you on page 165, and typically what they do with the consumer price index, the 100, remember 100 was important because it's the reference index. 100 reference index is between 1982 and 1984. Now, I'm not sure why they chose that. I'm sure we could Google it. I just have never done it. It's just commonly what they do. Like if you look on the U.S. Bureau of Labor Stats website, they do that as well. And your book did it as well, just to stay with how this is typically calculated. So the 100 reference year, I should say, really the reference year index is between 1982 and 1984. And if you look at this, like notice before 1980, 3-ish, or really in the middle of 1983 and 84, if you look before that, all the numbers are less than 100. And after that, all the numbers are greater than 100. So it kind of shows us the increase between those 2 years. So if we wanted just a basic, increase on the average rate of goods, your book does from 1995. So let's look at the actual question. I'm sorry. Where's the actual question? I got ahead of myself. Yeah, they want to find how much higher typical prices were in 2010 compared to 1995. How much more were the average price prices of goods and services, I'll just say goods, from how much more were the average price of goods in 2010 compared to 1995. And what's nice about the CPI is you can just choose those straight from the CPI value. So in 2010, if you look at the chart on the bottom of page 165, so I'm using page 165 here. If you look at the bottom of the page, the chart in 2010, we were at 218.1 for our CPI if we averaged it, if the 100 was in there somewhere. And then in 1995, we're at 152.4. And when you divide those out, you get 1.43. So the price of goods on average were 1.43 times higher in 2010 compared to 1995. Okay, the price of goods were on average 1.43 times higher. So, and now this is an average. That's not everything. We saw gas. Gas goes up and down. Everything else kind of goes up and down. It's rare to get something that just consistently increases right over time. But there's definitely some up and down aspect. But this is just the average increase on those goods. I mean, it was like 60,000, the value of 60,000 goods, right? So rate of inflation comes from this CPI. So the rate of inflation from, again, I'm looking at the book on page 166 now. The rate of inflation from one year to the next is the relative change in the consumer price index. So rate of inflation I'm just going to say comes from the increase of the CPI. Okay, it comes from the increase from year to year from the CPI. So the example the book gives you, it says find the inflation rate from 2011 to 2012. How does it compare to the inflation rate in the late 70s? Okay. Another piece of paper. So if we wanted to find the inflation rate from 2011 to 2012, rate of inflation, so we're going to do ROF for rate of inflation. You take the CPI, and I'm just copying this straight from the book, CPI from the more current year minus the CPI from the older year, and you divide it from the current year. The more current year, I should say. So if we look at this, the CPI for 2012 was 229.6 minus the older year, the year before, which is 224.9. And then you divide it by 229.6, and you wind up with 0.021. So we get a 2.1% rate of inflation. So from 2011 to 2012, we get a 2.1% of inflation, which is pretty normal. Your book says compare it to the 1970s. Did they give us a chart with the 70s? No, it just tells you that. Oh, price per note. I don't see rate. Oh, let's just, okay, wait, yeah. So the book did a rate of inflation from 1978 to 1979. And so from 1978 to 1979, the CPI, you would use the more current, so 79, I'm just going to be lazy, but 79, minus the CPI from 78, all over the CPI from 79. So when you do that, you wind up with 0.113, so really 11.3%. So look, in 1 year, from 78 to 79, the rate of inflation was 11.3%, which is crazy. And if you hear about your parents or grandparents talking about the 70s, this happened all through the Carter administration, okay? There was a huge rate of inflation going on during that time, okay? I don't know why. I'm not going into that. I don't know. Beats me. Okay. But notice it's more calm now compared to then. And I'll tell you, like, if we look at the rate of inflation from the last few years, I'm using this straight off the Bureau of Labor and Statistics. If we want to look at a more current rate of inflation, let's look this is from January 2018 to January 2019. Okay. So the CPI, the Consumer Price Index for January 2018 is 247.87. And the CPI for 2019, January, same month for 2019, is 251.71. So if I want to find the rate of inflation between those 2 years, or from January 2018 to January 2019, I've got to do the more current year, so 251.71 minus the older year, 247.87, and then divide it by the more current year, so 251.71. Now, if you put this in a calculator, make sure to put those parentheses around the numerator. The calculator I asked you guys to buy, I let my son borrow it, so I don't have it on me, or I'd show you what buttons to press. But you'll notice in that calculator, there's parentheses. So you need to do parentheses 251.71 minus 247.87 divided by 251.71. And I get 0.0153. So what that means is 1.53%. So that's a pretty slow rate of inflation. So the rate of inflation from 2018 to 2019, January of 2018 to 2019, is 153 or 1.53%. Cool. I'm just looking to see, like, what about through the pandemic here? Oh, that's interesting. Kind of flatlined. So anyway, kind of neat. Okay, so but that's how you find the rate of inflation from year to year. Okay, so then it asks, well, what if we wanted to kind of adjust prices for inflation? What if we knew the cost for something today, and we're like, well, I wonder what that was in like $1990. Or if I knew, like I purchased my house in 2011, just with rate of inflation, what should I be able to sell it with today to kind of break even, to stay up on inflation? That's what the next part of this section goes over. And it's called adjusting prices for inflation. So it says, given, I'm going to write this out and then we'll kind of fill it in with the example. So given a price in dollars for year X. So we've got year X and year Y. And again, we can go forward or backwards. It doesn't matter if one's newer or older. We just have to have 2 different years. So year X and year Y. The equivalent price in dollars for year Y. So they look at price for year Y is going to equal price in year X times, now the CPI for what we're looking for, Y, over the CPI of what we know, okay, X. And this will give us the price for inflation, okay? And okay, let's see. I can think of one off the top of my head. I don't know if I can go back and find it. Let's see. Oh yeah, no, I bought my first, I didn't buy it. My parents bought it. I'm going to be honest with you. But I had this little 2-wheel drive Sonoma, and it was purchased in the year 2000. So that's the year, for $3,500. And I want to know, well, what's that in today's dollars, right? What price would this be? And, or let's not do today, let's do 2019, because today's consumer price index hasn't come out yet. So let's do 2020 and $2020. Now I've got to look up 2020. I'm using January 2020 from the Bureau of Labor and Stats. So let's see what we know. So I'm going to say for our example, Y is going to be 2020, right? 2020. And X is going to be 2000. So the CPI of Y, now that's the CPI of 2020 I had to look up. It turns out to be 257.971. And the CPI for X for 2000, your book gives us as 172.2. Okay, they rounded just one, so let's round to 1 here. We'll say this is 0, and this goes up to 8. Okay, by rounding to 1 decimal place. So in the year 2000, the CPI was 172.2. The year 2020, the CPI was 258.0. Actually, last year, the CPI in January was 258.0. So if I want to know the price for my vehicle now, right? The price in 2020 is going to equal the price in 2000, which was $3,500, times the CPI in 2020, right? So 258.0 divided by the CPI of the year I bought it, 172.2. Okay, so let's see here. 3,500 times parentheses 258 divided by 172.2. And I'll wind up with 5,243.90. So the price of the vehicle for that truck, really, if you think of it in today's dollars. So in today's dollars, I'm looking at that truck being valued at $5,243.90. Okay. So in today's dollars, price for 2020, if we bought it today, I should have paid $5,243. Hope that makes a little bit of sense, right? We're just bringing it in today's dollar. Okay, so let's do this with a minimum wage to kind of show you what's, just for a current topic again. I'm not trying to get political on this, but just for a current topic. So let's say, again, the minimum wage, remember that federal minimum wage And let's do the 2000 again. That's when I had my first job. Remember, it was 515. And then we know that, let's see what that 515 should be at the current value, right? $5.15, if you include inflation, what it should be. So we know the current federal minimum wage was what, 725. Let's see if really it shows it should be above or below that, and the amount that, with it, if you include inflation, what it should kind of be at. Okay, that's what we're going for. So what is $5.15 in 2000 going to be in 2020? And you could say this a few different ways. What could $5.15 buy in 2000 compared to 2020? What could it buy now, right? That's another way to think of it. We're just using 515 as the minimum wage. So I'm going to use the same numbers, right? So the price in 2020, what we're looking for, is going to be equal to, now this is 515 times, now it's going to be the CPI for 2020, which we said was 258.0. That's from the last example. And the CPI in 2000 was 172.2. So this winds up being 515 times 258 divided by 172.2. We wind up with, you know what? Not too far off from what it currently is. $7.71. Actually, hold on. Yeah. No, that's how it would be. It's $7.72. So 515 in 2000 will buy the same amount as $7.72 in 2020. Okay. Now, I'm not going to argue if that's too high or too low. That's for a different class. But it is kind of interesting how, with inflation, the federal minimum wage has kind of stayed consistent. Okay. So $5.15 in 2000 will buy you $7.72 now. Now, if we want to argue what's the purpose of minimum wage and things of that, that's a different class. Okay. That's more like a political science class. But math class, that's what this shows. Okay. That's what this shows, which is about, I mean, if you were wanting to argue like, yeah, no, that's not what minimum wage is for, you probably wouldn't look at this data. But if you wanted to argue that that's exactly what minimum wage is for, if you wanted to keep it, then you would maybe look at this data, right? And say, no, we don't need to increase federal minimum wage. It's kept up with inflation. Okay, let's go backwards now. Let's say, oh my gosh. Yeah, let's look at, let's look at current rent. And let's choose, I don't know if we can do Mountain Home, if they'll, current rent prices, nah. Let's do current rent prices in, let's do it close. And they're so varied. Okay, right now I'm using some random website that we probably can't trust the data, but it says the average rent price in Little Rock, Arkansas. And you know, it varies so much depending on the size, depending on all kinds of stuff. But they're saying the average rent for an apartment in Little Rock is $850. Okay, the average rent price in Little Rock is $850 in 20. We're going to say 2020 because I can get the CPI for 2020. If you're thinking, well, how much would that have been in like 1990? What would this be in 1990 prices? Okay, what would this be in 1990 prices? Now remember, we're going to start with the amount we know. So $850 times, now we need the CPI for what we're looking for. Now I got to go back to the book, and the CPI in 1990, your book tells us, is 130.7. Okay, that's on the bottom of page 165 if you want to look it up, but it's the CPI for 1990 was 130.7. Now remember, that's the CPI of the year we're looking for, over the CPI of the year of the data we're given. So this is 2020. We're going to use that same 258.0. Okay, so I'm going to pop that in my calculator. 850 times 130.7 divided by 258. And we, holy cow, we wind up with $430.60 if we round to the penny. So an apartment that goes for $850 now should have gone for $430 back in 1990. And you got to think, I mean, the price of things was cheaper. It's like, oh, this seems cheap now, but in 1990, this wasn't cheap, right? I mean, the minimum wage in 1990, hold on, I can tell you. The federal minimum wage in 1990 was $3.80, right? I mean, if you're making a minimum wage, it's going to cost a lot for that $430 apartment. The same if you're making minimum wage now for the $850 apartment, okay? But it is relative in that manner. Pretty cool stuff. I know, you don't have to tell me. Okay, so for homework in this section, for homework, for 3D, we're looking at 1 through 43 odd. 1 through 43 odd, that starts on page, not 169, but 170. It starts on page 170. Okay, questions about this? You guys that are in the class, do you guys have any questions about these? Okay. Okay, well, and I'm going to tell you what I'm going to do for 3E. 3E is a little different. It's really about you reading it and then interpreting. So I'm going to put that on you. So for 3E, I want you to read, it's only like 4 or 5 pages. It goes from 172 to 178. That's 6 pages, not even 6 pages total, okay? I want you to read that, and I want you to look at the homework. The homework for 3E, it's in your schedule if you want to look it up in Blackboard. It's 1 through 29 odd. So I want you to work that homework yourself. This is an independent section. And if you come into problems or issues with it, I want you to email me and we'll talk about that. So it's a little different. It's kind of like outside of classwork, homework and just work in general, okay? So I want you to read that and I want you to go through the homework. And if you have any issues, just email me. So you might want to start there and then go back to 3D just in case you have any issues, okay? And that way you can ask me this afternoon or tomorrow. Now, the test is going to be Wednesday, right? Oh, I hope I might have said Thursday at the beginning of class. Test is going to be Wednesday. So you need to get that done either today or tomorrow. My lips are extremely cracked right now. Okay. So any questions on this? Any comments, any concerns? So 3E is going to be on the test, but I'll tell you, the questions from 3E are probably going to be almost identical to the book. I'm not going to get creative with the questions from 3E because of how I'm asking you to learn it. Okay. Now, so I'll probably just steal some examples and change the numbers. Hint. Okay. Any questions about, so right now we're done with the regular lecture. Are there any questions about the test coming up in 2 days? About what we're going to cover? I mean, it's 3A to 3E. Again, if you have any questions, email me, right? Email me. I'm going to be here. And I will reply. Now, of course, if you email me in the middle of the night, I might not reply till the next day, but just get with me and I'll get back with you. So I'm going to stop